Hello, welcome to my GIS class. A few years ago, this map was published in a reputable weekly British magazine to show which regions across the globe could be reached by missiles fired from North Korea and having a range of 10,000 kilometers. This map is very wrong, and it was ridiculed by geographers worldwide because it demonstrates in a great way how projections cannot maintain shape and size. To solve this problem with a real globe is easy. You take your globe, and as long as you know your scale, you can make 10,000 kilometers, and now you could just have a pin and you can make a perfect circle around the globe, and you would know which countries are inside and outside the range of 10,000 kilometers from any given location. To do that in a projection is a bit more challenging. Let me demonstrate. I have here a point file of Pyongyang in North Korea, and I have this file in two different projections. Once I have it in lat long, and I also have it in a regular meter projection such as UTM or other projections that follow the Cartesian coordinate system. In this case, I wanted to buffer first of all only by 5,000 kilometers. And I'm using the planar method, which is our default method. The result is very interesting when we use the meter projection and the planar combination, and here we see the result. A buffer that is completely wrong on many aspects. The one aspect is that it's not a circle, the other one is that it does not go beyond the date line, so the 180 degrees east. And if we were to measure 5,000 kilometers from Pyongyang, we would realize that the distances have not been calculated correctly. So what went wrong? What went wrong was that we violated the correct method here. When you look on the I button, it says clearly if the input features are in projected coordinate system, which we had in our case, then you need to create geodesic buffers, which means you have to go and do the shape preserving option. Let's see what happens if we choose this option, or alternatively if we simply use a point file that is already in lat long. Both options give exactly the same result, which looks like this. So here now we have true 5,000 kilometer distances from Pyongyang. Of course, they are not looking like a perfect circle because of our projection getting our 3D globe into the 2D plane, in this case of our computer screen. We can see that this is a perfect circle by viewing this 3D viewer here, and there we see the globe and we can see that it is a perfect circle. And now if I add my 5 kilometer planar buffer area, we just see again that this is a shape that is obviously very wrong. Now let's apply our 10 kilometer buffers, and I've done this already. Here is our buffer based on the planar system, obviously very wrong, and here is the correct buffer, and we can see how the distance from Pyongyang wraps around the globe, and again we can see this in 3D a little better. And we can see that the 10,000 kilometer distance of a missile can cover exactly half the planet. Here's one side of the planet, and here would be the other side of the planet. And here you see how the circular shape is looking when it's wrapped around the globe. So at the end of the day, the question is, do you want to create this map or do you want to create that map? The choice is all yours. So do you need to worry about geodesic buffering? I have only buffered features in real projects by a maximum of a few kilometers, in which case you can safely use planar. Only if you carry out very large buffer distances, which may have geopolitical consequences, you must consider geodesic buffering. That's all for now. I'll see you another time.